Another question on work. It says, okay, a 0.500 kg block rests on a horizontal frictionless surface, so there's no friction in here as shown in this figure. And somewhere here we have a force of compression to be 6 to 5 Newton per meter, and it's also compressing the same spring by 10 centimeter to point A1 to point A here. So it has compressed this up to that point A. Then the block is released. Now after the block is released, they are saying find the maximum distance D, this one there, which the block now does what? Travel. And they are saying the same incline is also frictionless, but the angle of incline is 30 degrees. B says how fast is the block going when it's halfway here. So here we need to take something into consideration. Still, we are talking about conservation of energy. Now we have spring energy, we have a height here, potential energy, and it's moving at the same time. We have kinetic energy, potential energy, and potential energy, which is due to spring. This is for gravity. So these are the three types of energies that we have here, and we need to answer this question just on these three types of energies forms. So let's go. So the first thing that we need to know for part A is that you need to know that this block here is at first is at rest. Take note. At point A here, it is what? At rest. That means kinetic energy at this particular point here is 0. Take note. So at this particular point here, we are saying kinetic energy here is 0. Even potential energy at this the same point here is what? 0. But the only form of energy that we have is the energy stored in this spring here, which is the potential, which is the elastic potential energy. All right, here it is there. There's no height, there is no velocity because it's from rest. So this is how you should be thinking in this way. Then you know that at point B is halfway. Remember, I haven't showed you that the height is halfway here. So at point B here, we have both. So at this point here, we have both potential energy and we also have kinetic energy. They are not equal to 0. They are there. The only thing is that these two are equal. Are equal because the height is halfway. Then at this particular point here, we don't have kinetic energy. Here kinetic energy equal to 0, but potential energy is there. It's there. I hope you are understanding how I'm breaking this down. At point C, we are only taking into consideration the height. And remember, kinetic energy is not defined by the height, but by the speed. And we don't have speed there. It's just the height. And it has reached where it's going, remember, at point C. So we don't have kinetic energy there. Now, why don't we have spring potential energy? We can't have spring potential energy here because there's no spring. The spring is at point A. That's all. Now, we can now break down this into this. So we have we have final and initial, right? We have where it's starting from and where it's ending. So in short, I say we have spring potential energy, which is given by what? Kx squared. Kx squared plus, okay, we have potential energy, which is what? Mgh plus we have kinetic energy, which is half mv squared. This is all what? Initial. This should be equal to the final one, which is just half kx squared plus mgh plus half mv squared final. That's conservation of energy. Now, initial, we are talking about this particular point here. And what did we say? Potential energy is 0, kinetic energy is 0, but we have spring potential energy there. So all these are zeros here. But the only thing that we have here at initial is this half kx squared equal to And what do we say about this particular point? At this particular point, we said kinetic energy is 0. Also, we don't have spring potential energy is also what? 0. So even what potential energy due to the spring is what? 0, but due to gravity is there. So this is 0, and there is 0 there. So we are only having m, g, h. But we are looking for this distance, d. Now I'll take you back to SOHCAHTOA. We have something like this, right? Where this is the height, and this here is the d, and this is the angle here, 30. We're looking for d. SOHCAHTOA, we know that sine theta is equal to opposite over what? Hypotenuse. In this case, our sine 30 equal to opposite is h, and hypotenuse what? D. Remember, so making h the side of the formula, h is equal to sine what? 30 times d. That means where there's h here, we are going to replace sine 30d. So we have h half kx squared equal to mg, then d, then sine what? Sine 30. This is still h. Then we'll take this one, and we're gonna solve it, of course. Okay. So we can get rid of the 2 here in front here, of course. So say, let me take it the other side. We have half kx squared equal to mg, then d, then sine what? Sine 30 degrees. Okay, so from here, we are looking for d, by the way. We're looking for d, the one which is here. So we can make d the subject of the formula. And how can we do that? We can divide all the way by mg sine what? Sine 30. And all the way here by mg sine what? Sine 30. So we get rid of that and that as well as that. So we have d, which is equal to half k x squared. You are dividing by mg sine what? Let's plug in the values. So which is half. The spring constant is 625. We are multiplying by. Now, here's one thing that you need to know here. There's one thing that you need to know here. Here is the thing. Let's go back. It says compressing the spring by what? 10 cm. It's not stretching, it's compressing. So there's a difference between stretching and compressing. Now, when this distance is being compressed, we take that as negative. When it's being stretched, we take it as positive. So since it's being compressed, we'll say that will be negative what? 0.1. Now remember, distance must be in meters. It was 10 centimeters. In meters, it's just 0.1. To be negative, of course, but we are squaring it. We divide by mass. The mass was 0.5 kg. Or you might be wondering, it's there, kg. And the gravity is 9.8. Wow, sine 30. I'm just gonna put it there. We know what sine 30 is, right? 0.5. So now we can punch that on the calculator. Let's now go deeper. So 625, 0.1 squared times what? 625, you divide by 2. I'm getting 3.125. I hope I get something like that. We have 9.8 times 0.5, again times 0.5. We have 2.45. So our D equals 3.125 divided by 2.45, giving me 1.28, which is 1.2755. But you can remember I said physics round off to 3 significant figures, and our D is equal to 1.28 meters. Wow, that was great. Then part B says, how fast is the block moving when it's halfway? Now, if we are going to use the same conditions here, now it's just like it's halfway now. So what are we saying? Here's what we are saying. We are saying the energies, okay, plus mgh plus half kx squared initial is equal to, sorry, this is mv squared half kx squared plus mgh plus half mv squared final. Well, we are just using the same thing. Here we are going to have this because we know that potential energy and kinetic energy at A is 0 or initial is 0. And here we are only going, now take you back. They're saying halfway. Remember that I said at halfway. I said potential energy and kinetic energy are equal. That means at B here, where the height is halfway, we have both potential energy and kinetic energy. So we're going to put that. We're going to have mv squared plus mgh. Now the h here, we are not using the full h here. We are using the half one. Take note. So we are saying hkx squared equal to half mv squared plus mg, but the height is half h. Now you can say there's half everywhere. You can just eliminate that, right? Will just give us kx squared equal to mv squared plus mgh. Of course, we can factorize m here, so which is common. So kx squared equal to m is common, so we remain with v plus gh. We can divide. Remember, we are looking for velocity anyway. We have m there. You can divide throughout by m, and we are getting v squared plus gh equal to kx squared. You divide by what? M. Then we can take gh the other side. So v squared equal to kx squared divided by m minus gh, and v, remember there's a square there, so it's just a square root of, let's now plug in all the values. K is 625. We are multiplying by what? Negative 0.1. Remember, we are still compressing, and the mass is 0.5. Then minus g is 9.8. Then the height, remember the height that we like, the height here, this one here, we can now find the h height since we know the value of d. From here, remember h is equal to sine 30d, and d we said it was 1.28. So here, remember, so here we can say h is equal to sine what? 30 times 1.28, and h, so sine 30, so sine 30 multiplied by 1.28, it's giving me 0.64. So h is 0.64. So we are going to put here 4. So v equal to, please let's punch that. So we have 0.1 squared, okay, of course, times 625, and we're dividing that by 0.5. So it's giving me to be this square root of what? 12.5 minus 0.64 times 9.8. It's giving me 6.272 in square. Then this, now after subtracting, I think that is giving me this. Remember 3 significant figures, right? That's all. So that's how you're supposed to answer this question. Please do not master physics. Don't master. Understand what the question is asking you to do. Then break down the concepts. That's all that you need. Thank you.